Dear students, welcome back. In this session, we are going to deal with low frequency physics regarding electrotherapy, that is the capacitor or condenser. So, capacitor is a device which is used to store electric charge. So, it works on a principle of static electricity. That means if the charged conductor is brought to another conductor, its stores increases, especially if the other conductor holds the opposite charge. So when you brought the two conductors, one charged conductor to the another conductor, so it stores, the another conductor stores more charges, especially if the other conductor holds the opposite electric charge. So this is the principle involved in the capacitor. So if you see the properties of the condenser, mainly it accumulates the electric charge, it blocks the direct current and passes the alternating current. Higher the frequency or higher the capacitance, more easily the current can pass. So this is the definition of the condenser or capacitor, the principle involved in it, and the basic properties of the condenser. Now we will see the construction of the capacitor. It consists of two metal plates, 1 and 2. It consists of two metal plates from materials with good conductivity and which are separated by an dielectric medium. This dielectric medium is mainly made up of with insulated material. When the plates are given opposite static electric charges, it leads to the concentration of electric lines of force, leading to the distortion of electron orbits of the atoms of the dielectric, thereby storing charges like the way a spring stores energy on stretch and give up energy when made to relax. Here what will happen if the two plates are given charges? So for example, it is given positive charges and the negative charges. So because of these two charges, so what will happen? So the lines of force exist in between them. So the lines of force exist between these two alternating charges. So initially, so if you take, this is the dielectric medium, so these are the particles in the insulated material. What will happen? So both the particles, both the atoms will have equal charges, negative and positive charges, and the electrons are tightly held by the nucleus when it is in neutral state. So these are called as polar molecules in a dielectric field when it is not charged with the electric field. That means normal. Now here these two plates are charged. So once these two plates are charged, what happened to the molecules here? So here these are the molecules which are arranged in the dielectric medium. Once charges are given, so here you can see, so this is the dielectric medium. So these are the conductive plates. These are the conductive plates and this is the dielectric medium, and it is connected to the electric source. So then one plate is getting positive and negative charges develop. So once this positive and negative charges develop on the plates, so then what happens? So the electric lines of force existing in between these two plates causes some distortion of the molecules. So what will happen? So here in this, so the molecules are very much disturbed here, so they are placed irregularly here when the electric charge is not connected, or without electric field we can call it as. Okay, next, so if after in the presence of electric field, what happens? The plates are having positive and negative, so the inside the molecules which are present in the dielectric medium will arrange in a such a way that, so to the positive charges all negative charges are placed, and to the negative charges all the positive charges are placed. So because of this kind of arrangement, these charges are tightly held together, and so after removal of this source also, it is having the capacity of storing this electric charges. So this is the main thing seen in the construction of the capacitor and how the charges are stored. So because of these molecules, if the insulating material is low, then there may be easy escaping of charges will taking place. If the insulating material is strong, then you'll have the more capacity. So the storage capacity is more for the capacitor. So that means when a condenser gets charged, there exists a difference of potential between the plates, which varies directly with the quantity of electricity and with which it is charged, and inversely with the capacity of the condenser. So normally the potential difference PD is developed in between these two plates. Okay, so when it is this potential difference is directly proportional to the amount of or the quantity of electricity with which it is charged, and inversely proportional to the capacity of the condenser. So if you want to calculate the capacity of a condenser now, so what do you mean by the capacity of a condenser? Here you should know the ability to hold an electric charge is called as capacity of a condenser, and it is measured in farads. Okay, so as we know that the potential difference between any two plates is directly proportional to the quantity of the electricity and also the capacity of the condenser. Okay, that means it is inversely proportional. If you want to calculate the capacity, then it becomes C is equal to Q by E, where C is the capacity measured in farads and Q is the quantity of electricity measured in coulombs, and E is the potential difference measured in volts. So what are the factors determining the capacity? So what are the factors which causes or which increases the capacity of a condenser? Now we will see. The capacity of a condenser depends on the surface area of the plates, material of the plates, width of the dielectric and material of the dielectric. If you see, as with a single conductor, a large surface area of plates results in large capacity. Some materials hold the electric charge more readily than others, and if the plates are of such a material, the condenser has a large capacity. That means if the conductor is having the large surface area, then it is having large capacity. Okay, now the material of the plates is also very important, that the plates which are that means the plates which are having to hold the electric charge more readily than others, such kind of material, such kind of plates of the condenser which is having larger capacity. Okay, so next coming to the dielectric. So we will see the width of the dielectric. So the dielectric which are used in between the two metal plates, what will happen if it is narrow? So if the width of the dielectric is narrow, there is a strong force of attraction between the opposite charges on each side of it. Therefore, what happened? So the charges are very much concentrated on the adjacent surfaces of the plates. So there is a strong electric field between them and marked distortion of the molecules of the dielectric. Thus, much energy is stored and the condenser has a large capacity. So if the width is narrow, then the electric field concentrated in between them is also more, and the molecular distortion in the dielectric also more, and the charges are tightly held with them and causes more energy to store up and the condenser, and which leads to the condenser which is having a large capacity. Okay, if width is more, then the opposite sequence is going to take place. Okay, next. If we see the material of the dielectric, so the material of the dielectric also affects the capacity, as molecular distortion occurs more readily in some materials than others, and these are capable of storing a greater amount of energy. So such kind of materials you have to select in the construction of the condenser. So like we can use some mica, ceramic plates like that. So we will see different types of capacitors afterwards. Okay, so these are all the factors determining the capacity of the condenser. What is the capacity of a condenser? Ability to hold an electric charge is called as capacity of a condenser. This capacity of a condenser depends upon the quantity of electricity measured in coulombs and also the potential difference which are developed in between the plates, and some of the important factors which determine the capacity only for determination of capacity or the surface area of the plates, material of the plates, width of the dielectric and material of the dielectric. Now we will see the types of capacitors. There are two types of capacitors. One is the fixed capacity capacitors and variable capacity capacitors. So now we will move on to the fixed type of capacitors. Here the capacity is fixed. There are different types of capacitors here. One is the paper capacitors, and so in the paper capacitor, so these are the two metal foils. In between them, paper is used as an dielectric. Okay, so here some wax paper are also used, and such kind of different types of arrangements of these foils can be seen. These can be arranged horizontally or this can be arranged in folds. Okay, and the next type of fixed type of capacitors are, one is the mica capacitor and the electrolyte capacitor. Here you can see. So in the mica capacitor, you can see the metal plates here. These are the metal plates. In between them, this yellow color is the mica sheets. So it consists of number of mica sheets arranged one above the other in such a way that there is a mica sheet between every two copper plates. Alternate copper plates are connected to terminals A and B here. Okay. So these are the different kinds of capacitors. In this mica, normally these are connected in parallel with each other. So the net capacity of the capacitor is equal to the sum of the individual capacities. This is also a capacitor of fixed type. Okay, and coming to the electrolyte, so these are the mica capacitors available in the markets. Okay, now coming to the electrolyte capacitors, it consists of a pair of aluminum plates dipping in a solution of aluminum borate. One of the plates, that is A, and which is connected to the positive terminal, and B is connected to the negative terminal of the source of a steady current here. Okay. Due to electrolysis, a fine layer of aluminum oxide is formed on plate A. This layer acts as a dielectric medium, whereas the solution, the entire solution along with plate B acts as cathode. Since the thickness of the dielectric is very small, the capacitor has a large capacity. So this is one type of electrolytic capacitor which can be seen in the markets. Okay, these are the various types of fixed type. Now we'll move on to the variable capacitor. So here, this is the variable condenser or capacitor. You can see here. These are the capacitors whose area of plates can be altered. So here the area of the plates can be altered to achieve variable capacitance. These capacitors are used in the radio sets for tuning and also in the shortwave diathermy machine for transfer of energy from the machine circuit to the patient circuit. Okay, so it is a condenser whose capacity can be varied at will. So it consists of two sets of parallel plates. So you can see two sets of parallel plates. So one set of the parallel plates are fixed here, and another set of plates are capable of moving when turned through a knob. So the movable plates are connected to the knob, and we can move the movable plates with the help of knob. When the knob is turned, the movable set can either be moving in or coming out of the fixed sets. So here you can see this is coming out of the fixed sets here. Okay, so here you can see the movable thing, and these will move in and these are coming up here, thereby changing the common area of plates as well as the capacity of the capacitor. When all the surfaces of both sets of plates are fully interleaved, the capacitance is at maximum. Okay, so this is about the variable condenser of a capacitor. If you see the electric field, how it is generated in between the two metal plates in a capacitor, the electric field between the plates of a charged capacitor consists of electric lines of force which tend to take the shortest possible route between the plates. However, they repel one another and pass more easily through some materials than others. So they are not always straight. They are all not always straight. And in this, so if you see in this picture, the effect of electric field on a matter which is offering less resistance than such kind of electric field we can see.